Hello, my name is Edward, and today we're going to be solving problem 6 of assignment number 10. So here we're given a function, and we are first asked to find the first and second derivatives. So I have the function written down over here, the original function. So to find the first derivative, all we do is that we find the derivative of cosine, which is negative sine. And as you can see here, we have two negatives multiplied by each other, so the end result is positive sine of x. So that's derivative 1. Then we simply find the derivative of this to find the second derivative. So the derivative of sine is cosine. So we simply get this 5 cosine of x. Now for part B, when we need to go and find which is the correct graph, as you can see here, red is second derivative and blue is the original function. So if we look at the second derivative, when x equals 0, the cosine will equal 1, so 5 times 1 is 5. So then it means that the red graph, when x equals 0, must have a value of 5, which means that graph A is the correct graph. Now for the last part, when we need to find the concave up and concave down of the original function, it all boils down to analyzing the graph of the second derivative. So whenever the red line is on the top, so as you can see here, you have the middle line when y equals 0. When it's above, it means that it's concave up, and the inverse is true for when it's concave down. So let's focus on concave up. So the first interval begins at negative 6.2 around and ends at about negative 4.5, as you can see over here. The second interval begins at negative 1.5, ends at about 1.5. And lastly, the last interval begins at around 4.5 and ends at 6.2. And keep in mind that the x value, 6.2, is actually somewhere over here. Now, to find concave down is simply the inverse. So the concave down begins at about negative 4.5, ends at about negative 1.5, and then the second interval begins at about 1.5, ends at 4.5. And keep in mind, when you write the intervals, make sure to write the u for the union symbol, and then you'll be all good.